In this session, we are going to discuss about the life cycle assessment. When we talk about the life cycle assessment, it is not only the embodied energy in the product. We are doing a project, and in that project, most of the items are accumulated. This discussion is going to be in the context of buildings. So how we can do the life cycle analysis and life cycle assessment of the buildings. So to create the building, we require some ingredients, and these ingredients are brought from various places, and then we do the construction of the building, and finally we operate the building, and end of the life we demolish the building. In this whole process, whatever are the emissions, they are known as total emission of the project, and that is assessed as per the life cycle assessment method. So life cycle assessment is done through a structured guideline that is based on ISO 14040 as well as 14044. These are the guidelines specified internationally to adhere to the life cycle assessment of the buildings. Especially when you talk about the construction industry, the code is EN 15978. So this is the code for the life cycle assessment 14040 and 44, and especially for the context of building sector, we have 15978 for the construction industry related life cycle assessment. Now, when you want to do the life cycle assessment, there are 4 phases of a building. So what are those phases? The first phase is the product stage. It's a common, so a couple of nomenclature you may find a little different, but this is common for anything apart from buildings also. So product stage means we are doing the planning of the building, and at the product stage we are doing the material sourcing, we are also doing the designing part of the material, and we are trying to optimize the material. The optimization, that means if you are having a 12-inch thick partition wall and you are designing your building in such a way that it can be used with a 9-inch partition wall, you are saving some material and you have saved the embodied energy, and not only you are saving the embodied energy, but you are also saving some material and overall cost of the building. So like that you can do the material efficiency for the building. You can think of a metallic structure, you can think of a cement and concrete structure, you can have various alternative natural products also whose embodied energies are much lower. If you are doing a project in India, and if you are sourcing your marble from Italy, then the embodied energy for transportation is going to increase, and that is the reason we say that we need to source the material from a local source. Even cement we should source from a nearby industry. That makes sense. So this is the product stage. When you are doing the life cycle assessment, they have classified the overall emission calculations based on 3 categories. This is as per 15978. So what are those emissions? The first category they have classified as A1 to A3 category. That means you are planning, during planning your office, your consultants, they are traveling, they are using some power, they are having some discussions, the office operation of the even consultants, that is also being used. So all that is part of your emissions during the planning. So A1 to A3 are the initial stages of the building level designing and implementation level emissions. You are doing that. And when you go to the next stage, that is the construction stage. When you do the construction of the building, you are actually sourcing material and installing those materials. So those type of emissions are in the category of A4 to A5 stages. that means you have transported material to the site, and suppose you are doing the brickwork. So to do the brickwork, whatever are the emissions happening, suppose you have sourced concrete from the factory, and now to pump the concrete slurry on the slab casting, you are doing some emissions. They are part of A4 and A5 stages of the life cycle assessment. For this purpose, when you are doing, then you can calculate the individual emissions happening. We have already discussed that what are the emissions. They are the emissions CO2, CH4, NOx, HCFC, PFC, SF6 and NF3. These are the 7 categories of emissions which are generally accounted as part of life cycle assessment. So we discussed that how we are calculating the emissions for the planning stage and during the construction stage, and the third type of emissions are during the use stage of the building. So this use stage is known as B1 to B7 stages. So what are those B1 to B7 stages? Then you are doing the project's operation. So your building is in use, the chiller is running. So whatever is the consumption in your chiller, cooling tower or your DG set or your IT servers, even lifts, so even the peripheral lighting. So whatever are the emission happening due to the uses of the building. Not only those things, but because you are doing the cleaning and you are sourcing some cleaning chemical, they are also part of the emissions related to your operation of the building. So these are the emissions which you have to account during the uses of the building, and this is categorized as part of EN 15978 B1 to B7 emissions. When you do the emission accounting, you have used various tools for doing this. We will discuss some of the tools because it's a very complex procedure to do the accounting. We will do a real case study and we will share the data for how we do accounting at the planning stage, how we do accounting at the construction stage, and how we do accounting at the operation stage. And not only the operation stage, if you are doing some retrofittation in the building, those are also accounted here. Suppose you are changing the facade, so those operations and retrofitations are also for the use of the building. And end of life. Building has been constructed and this will run, let us say, for 50 years is the life of building, and after that, if it is to be demolished, the energy used during the demolition of the building is also to be accounted, and those categories are C category, and you have the emissions accounting through the method of C1 to C4 type of emissions. We are giving you all these categories different nomenclatures from A1, A2, A3, A4, A5, A6, A7 and B1, B1 to B7 and C1 to C4. All categories of emissions we are sharing with you how they are accounted. So this is what we do the life cycle assessment. Now when you do the life cycle assessment for a building, this is done, let us say, to meet the requirement for your LEED certification. So the building construction level life cycle assessment is done in one of the credit category, and you have to create the baseline emissions of the building. The baseline emissions of the building, you have got the building's BOQ. This shows that how much cement, how much concrete, how much brickwork, and all complete civil work, then the aluminium, various some hundreds of materials are used as part of BOQ. So you have the base BOQ, and then you want to optimize your BOQ for savings. So LEED says that if you are able to achieve 10% reduction from your baseline energy design as part of your life cycle assessment, you get 1 mark. If you are able to get 20% saving, then you get 2 marks. We will discuss that in detail, how to do that documentation. But life cycle assessment has become part of your green building certification. Not only your construction stage, you have to do the assessment for your baseline and the project specific in your building operation stage also. So if you are operating a building and if you are sourcing green energy, your operational carbon emissions are going to be lesser as compared to sourcing a normal grid electricity. And that is what the concept of net zero we want to talk. Friends, building consume about 30% of our energy globally. The proportion is same in India as well. It is very important to focus on the building sector, improving building energy efficiency. We have a lot of stocks which are the operational building and lot of new stocks which are yet to come up. We need to construct good buildings, and if we do the life cycle assessment, we are able to find out that how we can optimize the CO2 emissions from my building's operation as well as during the construction. This is a very good area to those people who want to work in ESG reporting. These emissions are part of your organization's ESG reporting as well. I am sure we will take a real case study of a building, that how to do this accounting at every stage of the building. So be ready for my next session. Thank you very much for this.